Hello. So now we will study the convection as a process. So as we know, this is one more process by which the heat gets transferred from one location to other location. So in case of convection, generally we have a surface, and generally that surface is a solid surface. Sometimes it is a liquid surface also. So this is my surface and this side is the body. So this is the surface, this is the surface for my body. So and my body is having the temperature T. And this body is in contact with the surrounding, which is having a temperature T0, and obviously I'm assuming my body to be quite large as well as surrounding is also large. So these two temperature will remain constant over a period of time. So for this convection to happen, I'm assuming this T is more than T0, meaning the body is having the more temperature than the surrounding. So in that case, what will happen? There will be some surroundings molecule. This surrounding might be liquid, it might be gases also. There will be some molecules here which will be in contact with the body. So this body will transfer the heat to these molecules. These molecules, they will get the heat. When these molecules will acquire the heat, they'll have their kinetic energy will increase. When their kinetic energy will increase, these molecules will tend to move upward. Meaning these molecules will try to move to a place where the kinetic energy is less. So these molecules will move upside, and sometimes what we do, we try to force this motion also by blowing a air and blowing a liquid also. From here, we can force this motion, upward motion. So these molecules, while carrying the heat, they'll move upward, and along with their motion, they will take Q0 heat. This Q0 is dQ by dt we are talking about. It's a rate of heat. They will carry this heat and they will move towards the surrounding. And the new molecules which were above, they will take their places. These new molecules will take their places and this process will go on. The molecules will come down, they will acquire the heat, they will move up. You see? So this amount of heat which is moving up, amount of heat which is given by the body will be proportional to the cross-section area of the body. The thing is, if you see, amount of heat will depend upon the number of molecules, and the number of molecules in contact with this cross-section area will be proportional to the cross-section area. If it is more cross-section area, the body is having more cross-section area, there will be more molecules, more atoms which will be in contact with the body. So more number of molecules, more heat will be transferred, and the number of molecules are proportional to the cross-section area, so the heat will be proportional to the cross-section area. Rate of flow of heat will be proportional to cross-section area. Similarly, this rate of flow of heat will also be proportional to the temperature difference between the body and the surrounding. If there is a more temperature difference, in that case, the motion of these molecules will be a little bit faster. They'll move up with a faster rate and these molecules will come down with a faster rate. So if we combine these two aspects, the combination will become A T minus T0. So rate of flow of heat will be proportional to A multiplied with T minus T0. So this proportionality constant, we have to introduce some constant here to replace this proportional sign, and that constant is defined as B. So the formula becomes rate of flow of heat is equals to BA T minus T0. Here this B is a local constant, it is not a universal constant. Its value will depend upon the surrounding and the body in contact. Meaning if you change the body, B will change. If you change the surrounding, this B will change. Okay, this is our convective constant. Or we can say coefficient of convection. Okay, so this is our formula for the process called convection. Now in this formula, there is one assumption we are taking. We are assuming the cross-section area of the body. Basically, it's a flat surface we are assuming. If it is not a flat surface, if the surface is not flat, in that case, we have to take the effective area there. And the effective area is least for the flat surface. Effective area is equivalent to the cross-section area when the surface is flat. If it is not, then the effective area here will be a little bit more than the flat area acquired here. So this is our formula. By this rate, the heat will be getting transferred. Okay. Thank you.